everyone. So today we'll be doing some reducing agents, especially hydride based reducing agents. So let's get to the video. Reducing agents. As you all have heard about reducing agents, in redox chemistry we have done the reduction as well as oxidation occur simultaneously. So there what we observe is Zn. So here what we observe is that copper 2 plus is getting reduced, and how we get to know this? That the oxidation state is reduced by 2. So it is a process of reduction. Similarly, Zn is getting oxidized as the oxidation state is getting increased. So it is known as oxidation. In organic chemistry, if we talk about, as you all have heard about the functional groups like acid, ester, amides, aldehydes, ketones. So if a good example of reducing agent is acid, the oxidation state of acid is -2, -1 is +3. Now if we give some reducing agents, it will get reduced to aldehyde. Now the oxidation state has been reduced to -2 +2. So it is a process of reduction. Coming to hydride based some reducing agents, we will be doing some in this lecture, and next we will be doing continuing in the upcoming lectures. Lithium aluminium hydride, you all might have heard about it, a common reducing agent. Sodium borohydride, this also we have heard about. Third is sodium cyano borohydride. This I think will be new for you. Then is the Lugis reagent. Fifth one will be the BH3. And the last will be LiBH4. So we will be doing these many reducing agents in this lecture. Starting with the first, that is NaBH4, known as sodium borohydride. It is a mild reducing agent, that's why it will reduce only as aldehyde and ketone to alcohol. Okay. So since it will only, it is a chemoselective reaction. What do you mean by chemoselective? Chemoselective are specific for the specific functional groups. Like for aldehydes and ketones reduction, you especially will be using NaBH4. But if you are using lithium aluminium hydride, it is a very strong reducing agent. So it will reduce your esters, your acid, your amides, as well as your ketones and aldehyde.
Continue.
So it will reduce all these functional groups. It is a very strong reducing agent. Okay, coming to the third reducing agent, that is NaClBH3. This is a new one for all of you, I think. So what it will be doing is sodium cyano borohydride. What is the function of this? It will reduce your imine to amine. NHR. It will reduce your imine to amine. Now, how will you prepare this? This is easy. What you will do is you will take an aldehyde and you will give amide RNH2. So your H2 will be released and you will get this amine, then this will produce this imine and then produced by amine. Okay. The fourth reducing agent is Luce's reagent. Luce's reagent. What is the function of this? So Luce's reagent NaBH4 CeCl3 dot 7H2. This is the formula of this Luce's reagent. What it will do, as we have observed about this like system, conjugated system. So here we have two positions, 1, 2, 3, 4. So what we observe that if, let me remove this. So what we observe here, if we will be using NaBH4 here, so NaBH4 in the presence of ethanol, it will reduce both the ketone as well as your unsaturation. But if I am using a Luce's reagent here, so again it is a chemoselective reaction, as it will only reduce. Luce's reagent, what it will do, it will do 1,2 reduction. So 1,2 reduction, 1,2 means it will only reduce your aldehyde and your double bond will remain same. So it is a chemoselective reaction and it is specially used in place of NaBH4 for 1,2 reduction. 1,2 reduction. Okay, NaBH4 CeCl3, which is a Luce's reagent. Coming to the next one, which is what we left, boron, BH3. BH3, a very common Lewis acid, but it is also acting as a reducing agent. Why? Because it's a Lewis acid, so it will take a proton and form BH4 negative. So it is acting as a reducing agent. As from 0, it is getting reduced to negative. So it is also a very known as well as a common reducing group for acid. What will it will do? It will reduce acid in presence of ester. Allow me to give you a common example. Reducing, here we have an ester group and here we have an acid. In both ester as well as acid, which one is a more electrophilic or which one is more reactive is the acid only. Okay, so BH3, a Lewis acid, it will reduce acid in place of what we will observe. We will get alcohol. It will reduce acid directly to alcohol. This is the BH3. Next is LiBH4. Next is, this is the sixth one, LiBH4, lithium borohydride. So, what is the function of this? It will reduce ester in presence of acid. It's the opposite of BH3. What we observe there is it will reduce acid in presence of ester, but lithium borohydride, it will reduce ester in presence of acid. What will we get? Lithium borohydride. Acid will remain there and ester will get reduced. Okay, we can go ahead. So stop. So this much is for this video where we have covered 6 reducing agents which are hydride based reducing agents, and we observed that what are chemoselective reaction as well as what is the definition of chemoselective reactions. In next video we will be covering the next reducing agents as well as oxidizing agents. Till then, take care. Thank you.